Bruce here, people. The world of mixed reality is about to experience a major leap forward thanks to Meta's latest update for Quest developers. With version 74.0 of the Meta XR Core SDK, developers now have access to the RGB pass-through cameras of the Meta Quest 3, unlocking a whole new dimension of possibilities for immersive experiences. This is made possible through the new Pass-Through Camera API, PCA, a feature designed to bring real-world visuals into virtual environments with greater clarity and interactivity. While still in an experimental phase, this API represents a significant step toward bridging the gap between digital and physical spaces, allowing developers to integrate lighting, object recognition, and other machine learning-driven enhancements into their applications. With this powerful tool in hand, the next wave of mixed reality apps is set to be more dynamic, engaging, and lifelike than ever before. Stick around, and don't forget to like, comment, and subscribe if you want to stay ahead of the curve in the ever-evolving world of VR and MR. A new era for mixed reality developers. Mixed reality has been a core focus for Meta, with its Quest headsets leading the charge in creating hybrid digital-physical experiences. The introduction of the Pass-Through Camera API is a game-changer, as it allows developers to access the forward-facing RGB cameras of the Quest 3. This means that for the first time, developers can integrate real-world elements into their applications with higher fidelity and more advanced interactivity. Meta has long relied on pass-through technology to offer features like room mapping and basic augmented reality overlays. But the ability for developers to directly tap into the RGB cameras marks a significant upgrade. This feature allows for more accurate object tracking, real-time lighting adjustments, and the development of machine learning-driven applications that can analyze real-world environments in greater detail. Whether it's a game that reacts to the physical layout of a room or an educational app that overlays information onto real-world objects, the potential applications for PCA are boundless. What the Pass-Through Camera API offers. The Pass-Through Camera API, PCA, is a tool that enables developers to enhance their app experiences by leveraging the high-resolution RGB cameras on the Quest 3. This feature is particularly exciting for developers working on machine learning and computer vision applications, as it allows for more advanced object recognition and interaction with real-world environments. Meta has emphasized that PCA is designed to help improve app production quality. Developers can use real-world lighting conditions to create more realistic virtual overlays, ensuring that digital objects blend more seamlessly with the user's physical surroundings. For instance, shadows and reflections can now respond dynamically to ambient lighting, making mixed reality environments feel more natural. While PCA is still in its experimental phase, developers are already exploring its capabilities. The first applications utilizing this API are expected to appear on platforms like SideQuest and GitHub before making their way to the Horizon store in the coming months. Meta's approach ensures that early adopters can experiment and refine their apps before full-scale distribution. Current limitations and expected advancements. Like any cutting-edge technology, PCA comes with a few limitations. As of now, it is only supported on the Meta Quest 3 and the newly announced Quest 3S. The API provides access to camera feeds at 30 frames per second, with a resolution of 1280 by 960 pixels. While this is a solid foundation, developers may encounter challenges when dealing with fast-moving objects or smaller text due to a latency of 40 to 60 milliseconds. These limitations mean that while object tracking and real-time analysis are possible, applications requiring instant feedback or extreme precision may need further optimization. However, as Meta continues to refine its technology, it's likely that future updates will improve both the frame rate and latency, making PCA even more viable for high-performance applications. Another key consideration is that users must grant explicit permission for apps to access the PCA, similar to how microphone and location permissions work. This adds an important layer of security, ensuring that users have control over how their camera data is utilized. Early use cases and developer adoption. Despite its experimental status, PCA is already generating excitement within the developer community. At this year's Game Developers Conference, GDC, major studios like Niantic, Resolution Games, and Creature are showcasing early implementations of the API. These companies were given early access to PCA and have developed demonstrations that hint at the possibilities this technology offers. One of the most intriguing applications is the use of PCA for QR code tracking and object recognition. This opens the door for experiences where real-world items can interact with digital overlays in meaningful ways. Imagine pointing your Quest headset at an object and receiving instant contextual information, or using real-world props as interactive elements in a VR game. Additionally, OpenAI's visual model integration has been tested with PCA, enabling real-time analysis of images, which could be revolutionary for both gaming and productivity applications. To help developers get started, Meta has released a series of Unity samples on GitHub, demonstrating core functionalities like real-time object tracking, depth analysis, and lighting adaptation. Furthermore, developer Roberto Coviello has contributed additional tools through Quest Camera Kit, expanding the ecosystem of resources available to those eager to experiment with PCA. The future of mixed reality with PCA. The introduction of the Pass-Through Camera API signals a clear direction for Meta's vision of mixed reality. By providing developers with direct access to RGB camera feeds, the company is laying the groundwork for applications that seamlessly merge digital content with real-world environments. This shift moves beyond traditional VR experiences, pushing toward a future where our physical and digital worlds are truly interconnected. In the short term, we can expect a surge of experimental applications appearing on alternative platforms like SideQuest, where indie developers and pioneers in MR will test the limits of PCA. As the API transitions out of its experimental phase and becomes fully supported, the Horizon Store will likely see a wave of high-quality MR applications incorporating PCA-driven enhancements. Beyond gaming, this technology has vast potential for industries like education, training, and remote collaboration. Think of a classroom where students interact with 3D holograms projected into their actual environment, or a remote work setup where digital tools overlay onto real-world workspaces, creating a next-level augmented office experience. The possibilities are as exciting as they are endless. Keep an eye on platforms like SideQuest for the first groundbreaking applications, and expect even more polished experiences once Meta officially rolls out full support for the API. Don't forget to like, comment, and subscribe if you want to stay updated on the latest advancements in VR and mixed reality, because the best is yet to come.